Yes,
Yes,
sir.
yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
Okay, Ji. So the circuit which we have seen, it is called positive clamper circuit. Why? Because it is shifting the signal in the positive direction, like this, right? So it is basically a positive clamper circuit which shifts the signal in the positive direction, right? Similarly, if we consider the same diode which we have seen, if we consider the same diode not as an ideal diode but as a practical diode, right? Are you with me?
Yes, sir.
Yes, sir.
Okay, if we consider the same diode as a practical diode, so what will happen, right? Let's see it again. So we know to turn on a practical diode, to turn on the practical diode, we need to have 0.7 volts for a silicon diode to become a forward bias, right? So this means that 0.7 volts needs to be given provided that the diode should turn on, right? So after 0.7 volts, whatever the voltage which will be available, that is going to actually charge the capacitor. So let's see it again. What will happen now? That let me just show you that. Let me redraw it. Now we have the same circuit, but now the difference is the diode is not an ideal diode, but the diode is a practical diode, right? And we are applying the same sinusoidal signal. So to have the diode that needs to be forward bias, we need to have 0.7 volts for the silicon one and 0.3 volts for the germanium diode one to be across the diode, right? So now, before, again, the criteria of the analysis of the clamper circuit is the same, that we will start the analysis with the cycle which makes the diode forward bias, right? So the same analysis goes over here as well, that we will start the analysis with that portion of the input waveform that makes the diode forward bias, right? So again, we are starting with the negative half cycle. When we are starting with the negative half cycle, so this means the lower end of the DC, the lower end of the voltage source will be positive, and the upper end of the voltage source will be negative. Are you with me up till this point?
Yes, sir.
Yes, sir.
Okay, Ji. So once we have concluded this, so this means once we are going to have a rise in the negative half cycle like this. So before 0.7 volts, the diode is not going to turn on. So this means once the diode is not going to turn on, so this means the capacitor is not going to charge unless and until the potential across the diode will be equal to zero point 0.7 volts, right? So once the input rises above 0.7 volts, so this means the diode will turn on, right? And once the diode will turn on, then the current will start flowing through the diode and it will be charging the capacitor in this way. So this means the positive charges will be accumulated on the capacitor on this specific plate, right? Now, as long as the input is rising, as long as the input is rising, the charges which are accumulated across the capacitor, they will also rise according to the time constant. Again, the resistance which is being offered by the diode is very, very small, right? So due to this, the time constant in this case, it will be C into RD, where RD is the resistance of the diode, right? Which is being offered. Again, the resistance of the diode which is being offered is very, very small. And due to that small resistance, the capacitor will again going to charge instantaneously. So as long as the input is rising to the value equal to Vp, the capacitor is going to charge equal to the value Vp minus 0.7 volts. Are you with me?
Yes, sir.
ठीक है जी. So once the capacitor is being charged to the value equal to 0.7, This means at that specific point, the input is at VP, right? Are you with me?
Yes, sir.
Yes, sir.
Okay. Now, after that, the input will start decreasing from the value equal to VP. When the input will start decreasing from the value equal to VP, the diode is no more forward bias, because the potential difference across the diode is no more 0.7 volts. Are you with me?
Yes, sir.
Yes, sir.
Sir, repeat, please.
Okay, if I say let's suppose VP is 10 volts, right? If I say VP is 10 volts, right? So the potential or the voltage which is across the capacitor, it will be equal to
9.3
10,
volts.
10 minus 0.7.
it will be equal to 9.3 volts, right? So this
Yes,
means
sir.
this end, which is the P side of the diode, it is equal to 10 volts, and the other side is equal to 9.3 volts, right?
Yes,
Are you
sir.
with me?
Yes, sir.
Yes, sir.
Now, once the input will start decreasing from the value equal to VP, what will happen? That the drop across the diode is no more equal to 0.7 volts. And once it is no more equal to 0.7 volts, so this means the diode will not remain forward bias, but it will become reverse bias, right?
Yes, sir.
And once it will become reverse bias, so this means again the practical diode behaves as an open switch when it becomes reverse bias, right?
Yes, sir.
And once it will become reverse bias, the circuit can be shown something like this over here, but previously it was VP. Now in this case it will become VP minus 0.7 volts. Are you with me?
Yes, sir.
And once this is the case, so again we apply KVL to this circuit. When we apply KVL to this circuit, the equation will become something like this. The equation will become V naught should be equal to VP minus 0.7 volts plus VI. Are you with me?
Yes, sir.
If you look at the circuit, so the circuit shows that if we apply KVL to this circuit, it will be equal to V naught should be equal to VP minus 0.7 volts plus VI, right? And this is the situation when the input is actually rising above or it is getting into the positive half cycle. And this is the equation we are going to get. V naught is equal to VP minus 0.7 volts plus VI.
आपका इंटरनेट बहुत वीक है सर।
यार अब मेरे हाथ में तो ये नहीं है, आज कुछ पता नहीं है, इट इज गिविंग ट्रबल बट आई एम ट्राइंग टू कोप विद इट। ठीक है जी, ओके, जस्ट होल्ड ऑन, ठीक है जी। सो व्हाट वी कैन सी दैट इफ VP, if you see, if we want to see what is going to be the value of V naught maximum, so we can say V naught maximum should be equal to VP minus 0.7 volts plus the what is going to be the maximum value of VI. If you see again, so it will be VP. So what we can write, VP minus 0.7 volts plus VP, right? So this means that this value should be equal to 2 VP minus 0.7 volts, right?
Yes, sir.
And if we want to see what is going to be the minimum value, so again you see the minimum value in this specific case for VI should be minus VP,
Yes, sir.
right? So putting the value for V naught minimum, we can see that the equation over here should look
Minus.
like VP minus 0.7 volts plus in the bracket minus VP, right? So this means it will be equal to V naught minimum should be equal to minus 0.7 volts, right? Are you with me?
Yes, sir.
So if we want to see the waveform over here, so this means the waveform maximum value will go up to 2 VP minus 0.7 volts, and this will go 0, and this will be our minus 0.7 volts, and this will be VP minus 0.7 volts. Are you with me?
Yes, sir.
So this means the variation of the signal is now in between 2 VP minus 0.7 volts and minus 0.7 volts, right?
Yes. Yes.
So again, the signal is being shifted in the positive y-axis. So therefore, this circuit is called positive clamper circuit, right?
Yes.
And similarly, if I change the direction of the diode in this circuit, right? If I change the direction of the diode in this circuit, so what will happen? That change the direction of the diode in the circuit. And if I change the direction, it will become like this, right? Now, if you see, we can start the analysis again. And when we start the analysis, so जी हुमैरा, आप क्या पूछ रही हैं? Question? Question? Okay. So can you hear me?
Yes,
Yes,
sir.
yes.
Okay.
Yes, sir.
Okay. So now we change the direction of the diode in the circuit with the same input signal. So we start our analysis with that specific portion of the input signal which makes the diode forward bias. So now as the direction of the diode is changed, so this means the portion which makes the diode forward bias is going to be our positive half cycle.
Positive half cycle.
So when we start our analysis with the positive half cycle, so this means this end is positive, this end is negative, right? And again, we start with considering the diode as an ideal diode. So when we consider the diode as an ideal diode, so this means the current will start flowing like this or here, and we will be taking V out across the resistor. And once this is the case, so if the diode becomes forward bias, so this means the current starts flowing through it, and the diode will behave as a closed switch. And once the diode will behave as a closed switch, so this means this end of the capacitor will become positive, right? Once this end of the capacitor become positive, and as the diode is behaving as a short circuit switch, so the time constant in this case will be capacitor into the resistance which is being offered by the diode. And in this case, the resistance which is offered by the diode is short circuit, and the short circuit resistance is almost negligible, which is equal to 0. So this means the capacitor is going to charge instantaneously because the time constant is very, very small. Are you with me at this point?
Yes, yes.
Yes,
Hmm.
sir.
ठीक है जी. So this means that as the input signal rises, the capacitor will be charging at this very same instant. When the input to the maximum value, which is Vp in our case, so at the point when the input reaches to Vp, the capacitor will be charged equal to the value equal to Vp, right? Now, when the input start decreasing from the value Vp, so what will happen that the diode will no more be forward bias, right? And once the diode is no more being forward bias, so it will become reverse bias. So when it will become reverse bias, we can see that this diode over here will behave as an open switch. It will behave as an open switch. And once it will behave as an open switch, so for whole of the rest of the positive half cycle, it will behave as an open switch, and for the next negative half cycle, it will also remain as an open switch. So this means the now the to make the circuit simple, we can just show that this circuit will be looking something like this. Right? So it is something like this. So this end is positive, this end of the capacitor will be negative. And after that, we will be having a negative half cycle. So this means this end is negative, this end is positive of the input voltage source. Are you with me?
Yes, sir.
Yes, sir.
Right? So this is the simplified version of the circuit, and what we can do, we can apply KVL to this circuit now. When we apply KVL to this circuit, so the equation which we are going to get from this, it will be the equation which we are going to get, it will be V naught should be equal to minus Vp and minus Vi. Are you with me?
Yes, sir.
Right? So if we want to see what is going to be the value of V naught when Vi is maximum, so if we put Vi maximum value, which is equal to Vp in our case, right? So
Yes,
it
sir.
is Vp minus Vi maximum value, which is also equal to Vp. So this means V naught can go up to minus 2 Vp. Are you with me? So this is going
Yes,
to
sir.
be limit of the output voltage, and if we want to put the minimum value of Vi in the equation, so what we will see that we can say V naught is equal to minus Vp minus in the bracket minus Vp, right? So this means V naught will be equal to 0, right?
Yes,
So the
Yes, sir. Thank you, sir.
so this means the variation of V naught will be in between 0 and minus 2 Vp. So if we want to draw this output of V naught, it will look something like this. We have a variation from 0 to minus 2 Vp. So we have 0, we have minus Vp, and we have minus 2 Vp. So the output will be varying from minus Vp to 0, and then back to minus Vp, and then back to minus 2 Vp, right? So in this way, if you see, the output is varying in between 0 and minus 2 Vp. So the signal is being shifted in the negative Y direction, and such kind of an output is normally being called as negative clamping, and the circuit which performs this function is called negative clamper circuit, right? Any question?
Thank you, sir.
That's fine.
Yes, sir. Fine.
Yes, sir.
जी वकार साहब सो है
सर यहाँ पे हमारे पास जो ग्राफ में शो हो रहा है तो जीरो हमारे पास मैक्सिमम वैल्यू नहीं आ रही, लेकिन यहाँ पे हम वी नॉट मिनिमम लिखते हैं जीरो को।
नहीं देखें अगर आप यहाँ पे एक मिनट चेक करें तो व्हाट आई हैव रिटन वी हैव रिटन दी v naught 0 as well as v naught minus 2 vp. These are the two limits, but the value of vi when we are putting vi is equal to vp, we are getting minus 2 vp. That is one limit, right? And the other limit is when we are putting vi equal to minus vp, we are getting 0, right? So
Right.
these are the two limits, and once we are taking these two limits, we are drawing between them the output, which is from 0 to minus 2 vp.
Okay.
Okay, okay.
Yes, sir.
So now in this was the case when we were considering the diode as an ideal diode. Now what if we consider the diode as a practical diode, right? So replacing this with a practical diode, if we replace this with a practical diode, so again it is the same circuit, but now the difference will be that the diode to turn on or to become a forward bias, the drop across the diode needs to be equal to 0.7 volts, right? So this means that the charges which will be accumulated across the capacitor, on this side it is positive, on this side, on the other plate it will accumulate negative charges, right? And when it will accumulate negative charges, so it will charge up to minus vp plus 0.7 volts, right? Are you with me?
Yes, yes.
Are you getting this point? Because one plate is getting positive charges, the other plate will be getting negative charges, right? And once you go into the loop, so you will see that the drop of the diode is positive, but on the plate which is adjacent to the p side of the diode is positive, so the net charge or the net maximum charge on the capacitor which it is going to accumulate will be minus vp plus 0.7 volts, right? Are you with me?
Yes, sir.
ठीक है जी? So
Yes, sir.
once the value of the input starts reducing from this point, the diode will no more be forward bias, right? And once the diode is no more forward bias, it will become reverse bias. Are you with me?
Yes, sir.
Yes, sir.
So once the diode becomes reverse bias, so this means we can replace the diode with an open switch, right? And once we replace this with an open switch, so the diode will remain as an open switch for the rest of the positive half cycle as well as for the negative half cycle, right?
Yes, sir.
Yes, sir.
So this means we can have the simplified circuit over here, which is being showed over here, right? So it will be minus vp plus 0.7 volts over here, and we have taken out the reverse biased or open switch from the circuit. Right?
Yes, sir.
And if we apply KVL to this circuit now, so the equation will become VP. The equation will become minus VP plus 0.7 and minus VI. Right? Are you with me?
Yes, sir.
So this means if again we put the maximum value for VI, the output will look like minus VP plus 0.7 volts and minus VP, right? Or this will look like V naught is equal to minus 2 VP plus 0.7 volts, right?
Yes, sir.
And similarly, if we put the minimum value of VI, we will have the equation that will look like minus VP plus 0.7 volts and then minus into minus VP, right? So the value of the output will look like plus 0.7 volts. Are you with me?
Yes, sir.
ठीक है
Yes,
जी?
sir. Yes, sir.
And this means we can simply draw the output which will be in between 0.7 volts and minus 2 VP. This means the output will be something like this. This will be 0 and this will be 0.7 volts and this will be minus 2 VP plus 0.7 volts and this minus VP plus 0.7 volts, right? Okay, the session is going to end now because we are again reaching to the 40 minutes limit, and we can stop it over here. ठीक है जी? So thanks everybody, and you can take a look of the session on Google Classroom. So thank you everybody.
Sir, excuse me, sir.
ये सेशन खुद ही खत्म हो जाएगा जी
ठीक है सर,
जी जी।
अटेंडेंस का तो कोई वो नहीं होगा।
अटेंडेंस जो नए रोल अमीन साहब यहाँ पे हैं, आप दोनों सीआर जो नए रोल अमीन साहब को अटेंडेंस भेज दें, ठीक है जी?
ठीक है सर, ठीक है।
Okay, okay, thank you. Session is anyway is going to end by itself.
Thank you, sir.